Hi, thanks for the opportunity to present today. I'll be presenting the work so far on the NIRS analysis pipeline. This work was a big, fruitful collaboration between the Michael Bohr lab and the Lucas Mueller lab. And I want to give a big thanks to Jenna Hirschberger for her work on the R Waves package. Waves is really the engine behind this work, enabling a variety of different model algorithms for fitting NIRS data, as well as different cross-validation schemes. And so I invite you to take a look at her article and to look at the documentation for the R Waves package. So you could use it on your own outside of Freebase if you want to. But of course, here I'm presenting an integration we did with the R Waves package and Freebase. And so this involves bringing the data and the analyses together. And so here I want to start um, with a schematic. So you imagine a user and they have a near infrared spectroscopy data in a comma separated file on their computer. And assuming they have an internet connection, they could interact with Breedbase, the Breedbase web service. And through that web service, they could upload their near infrared data into the Breedbase database backend, and it would be stored in our JSON-B format that we developed. And then the user could continue to interact over the web connection. And they have access to query tools that enable data export, so they can export their own near infrared data as well as um, the aggregated data from other experiments and other users. That data export can be in the format of a file, comma separated file, but it could also be the Brappy reading API format. And with Breedbase serving as a wrapper over the R Waves package, it can also produce plots. So as we'll see later on, this is a plot of the near infrared spectrometry data itself for a number of samples. And the Waves package enables the analysis pipeline, which involves 4 steps. First, training the model for a phenotype of interest, then saving the model into the database, then later predicting new phenotypes uh, for new near infrared spectroscopy data, and finally saving those newly predicted phenotypes. And of course, the user can continue interacting with Freebase to then export, those predictions and those models. Um, Now moving to the demo portion. So here I'm on a local instance of Freebase. And so here I show the near infrared spectroscopy data format that users should use to upload data into the database. You'll notice the first column is of sample identifiers. Then we have 2 columns here, the device ID and comments. These are optional. And then finally, there's columns for all of the different spectra, and these columns are just headered by the wavelength of the spectra. So here from 350 up to 2500, I believe. And so here, um, in this database instance, I have a single field trial, and it has it's just a test field trial with 20 plots, and it has um, these 160 tissue samples, and those samples match up to the identifiers in this file. So that's what's already in the database. Then if I go to manage NIRS and upload, I can select the near infrared data type. Here I can create a new protocol. So I'll just call it NIRS1. And this is testing. And then finally here I can select that data file I just showed. And this is a verification and then a storage step. Here's that plot coming out of waves, where on the x-axis is the wavelengths and the spectral values on the y. And this identifies any outliers in the data and removes those outliers. And then here we can store the data. Okay, so it says the upload was successful. So now that was the upload. We can, as I mentioned, you can download NIRS, you can plot various spectra. But the first thing is to train a NIRS model. And for this, we first need to create a data set. And data sets are created through the wizard. So they are, here I'm creating a data set with that field experiment, the sessions involved, as well as this trait, dry matter content. So here I can say, I can create that. If I then go back to the NIRS page, I can train a NIRS model. So I first select a data set of the one I just created. Go to the next. You can specify a testing, but if you don't, it'll be randomly partitioned from the training data set. And you select the trait that you want to train the model against. And then finally here, there's various algorithms in the waves package, the partial least squares regression, and there's a few tuning parameters that can be specified. So here we see the model was trained. We can see some summary statistics coming out of the model. We can save the model. So here, let's say it's here's model test 1, and it's public. So the model was saved. The models in Preface have their own they're their own object. So you can download the RDS file. So this is like the saved weights um, in that partial least squares regression, and you can download the data that went in and the output of the model. We go back here, then we can predict phenotypes um, by feeding in new near-infrared spectral data. So in this case, I'll just use the same data set as before. Here, you select the model that you want to predict against. And so we see the predictions um, for the plots in the data set that we selected. And we can then save those predicted results. And so it was saved. And we go to the analyses page. The predicted phenotype is here. The trait is it's a combination of the trait that was predicted and the algorithm that was used. And now every analysis is through a model. So that's what's that linkage is demonstrated here between the model page and the analysis. And those predictions can be downloaded. So here they are, and they're readily accessible. So with that, I'd like to thank everyone in the Mueller lab and Jenna again, and the Michael Ward lab, as well as Chris Samoas and Brian Ellerbrock in the Mueller lab. And if you have any questions, feel free to reach out. Thank you.